This video is to complete the notes page 12. I'll give you a moment to go ahead and write in the learning target. I can simplify basic expressions using trig. Trig is short for trigonometry. Alright, so at the little box that you have on top of your page, this was meant to write in the three trig identities that we have so far. So the first one, cosine squared plus sine squared equals 1, 1 plus tan squared equals secant squared, and lastly, cotangent squared plus 1 equals cosecant squared. Now we're going to be using these identities to simplify some trig expressions using our factoring skills. Alright, take a look at this. When I look at this, my first step is to identify a common term that's common to this term and this term, or common factor. So I noticed that right here this 2 is in common. I didn't do anything new at this step. What I did is I just highlighted the 2 so that I'm taking a mental note that I'm noticing that 2 is common here and it's common in my second term here. So I go ahead and factor out that 2. What I'm left over inside the parentheses is cosine squared plus sine squared. That's when I'll be using my Pythagorean identities. I'm going to look up here and I notice that cosine squared plus sine squared is equal to 1. So this part inside the parentheses becomes 1. 2 times 1 is equal to 2. And we are done. So as you can see, we simplified this ginormous expression into 2. This expression is just equivalent to 2. This is how we'll be using our Pythagorean identities to simplify trigonometric expressions. Example 2, we have this, it has a fraction. So here I'm actually not going to be factoring out anything, but what I am going to do is I notice that this top part right here looks very similar to one of my Pythagorean identities, specifically Pythagorean identity number 1. That's why I highlighted that part in red. That part in red is going to become 1, because as we know, cosine squared plus sine squared is equivalent to 1, and that's pretty much it. This expression right here simplifies to simply 1/3. Alright, example 3, I'm going to go back and be using the technique that I used in example 1. I identify a common term or common factor. So here, look at the first term, I notice there's a 2. And this second part, the second term right here, there's also a 2. So in my mind, I'm making a mental note that, hey, 2 is in common. What I'm going to do next is factor out the 2, and in parentheses, I'll leave what's left over inside, which is just going to be 1 plus tangent squared theta. Again, because I factored out the whole 2 from this part, you're just left over with 1. It's just a little note there. Now, I take a look at what's inside my parentheses, and I notice this looks a lot like what's in Pythagorean identity number 2. 1 plus tangent squared is actually equal to secant squared. So this stuff in parentheses will become secant squared. That's pretty much all I could do to simplify this. So what I'm going to do is drop my parentheses and finish up. That's it. This would be my answer. Alright, let's move on to example 4. Example 4 has a fraction and it also has an opportunity to factor out a common term. First step, my eyes are going to go to the part that has the trig function, which is up here in the numerator position. I notice there's a 3 and a 3 here. So this is my first term, this is my second term. They both have 3, so I make that mental note, like I see that 3. So all I did is I highlighted that 3 in red. Now what I'm going to do next is factor out that 3, leave what's left over in the parentheses, and then try to pull out my Pythagorean identities and see what that stuff in parentheses equal. So 1 plus cotangent squared is the same thing as cotangent squared plus 1, and it's equal to cosecant squared theta. So this part right here is going to become cosecant squared theta. Alright, after that, I don't see any other way I could simplify this further. So what I'm going to do is drop my parentheses and have my answer. So as you can see, we are simplifying because this larger expression did condense into a smaller one. So that is it. That was our notes, page 12.